Pivoting from art to science. So very quickly, who's this guy talking in the old OCS Navy class sweatshirt here? So my name is Joe Slowik. Currently, I'm a threat researcher at DomainTools. Previously, and you may know me from my time at Dragos, working with Rob, among others, where I was an adversary hunter. And before that, I led the CSERT operation at Los Alamos National Lab at DOE. DomainTools, probably very familiar with them if you're in the CTI space, just as a provider of threat intelligence. And I know we've got something going on the solutions track later today. So if you want to know more, check that out. But anyway, jumping right into our agenda, what is pivoting is going to kick us off to things, and that's going to lead us into a discussion of indicators of compromise, a fairly common subject when it comes to CTI discussions. But we're going to look at IOCs not as items in themselves, but rather as composite objects that's going to get us into behavioral profiling that'll let us talk about pivoting through composite matching and try to drive us from pivoting as intuition towards pivoting as a systematic process, which actually was highlighted rather well in the keynote today from the folks from FireEye Mandiant. So pivoting, how does that work? Well, you might see a lot of sort of guidelines. They're not so much as rules as they are guidelines or whatnot. You'll hear people say no more than 3 pivots for one reason or another, or 1 pivot only to remain very close to the source data set and similar observations. But the thing is that these are all sorts of intuitions and generalizations. And as we see within actual examples, it's very much possible to pivot depending on the information that you have available or how unique an adversary is operating, to pivot almost infinitely. And in other cases, like we were seeing with the sunburst related activity, pivoting, at least in external data sets, may be quite difficult because of the nature of how the adversary is operating. So there is some guidance that exists for how pivoting works. We've seen work from FireEye, from Threat Connect, among others, that have gotten into a documentation of pivoting processes. But most of these, however, are very much focused on vendor-specific solutions or vendor-specific data sets. Not to say that they're bad, just means that if we're really trying to drive the field of CTI forward in such a fashion that we can get at a generalized understanding of pivoting as a process that's applicable across multiple data sets, multiple platforms, it's not terribly helpful. So certainly I recommend reading these if you'd like more information, and there's a resources section at the end of this presentation with links to these among other items. But, ultimately it seems in practice that pivoting for the most part is something that in practice is looking into the crystal ball and sort of divining things through intuition and other gut feelings of how data is related to one another. And that doesn't seem very sustainable or desirable. But in the end, when we look at pivoting, and we've seen this in multiple talks during CTI Summit, as well as multiple other works of CTI interest, pivoting ultimately seems to boil down to indicators. I'm going to push back on that in a little bit, but indicators certainly become an important part of both driving the pivoting process as well as a output of pivoting or the results of a pivoting exercise. So indicators, how do they work? Well, in application, we might be familiar with indicators in the sense that we block them, we alert on them, we get lots of blocks or alerts if they're really bad indicators, like alerting on 8.8.8.8, or we get no alerts because that indicator was very unique to the item in question. So from defensive purposes, yes, there might be some consternation surrounding these items. But indicators of compromise have their problems as well, or at least have historically have their issues in CTI. And we could look at this from the original Grizzly step reporting as symbolic of that issue, where we see a bunch of domains, IPs, URIs, etc., no real enrichment in trying to figure out what's going on here. And that seems less than desirable, not just from a intelligence standpoint, but also from a pivoting standpoint, because what do I do with these sorts of things? Well, really, if we start looking at indicators of compromise as they were originally intended, though, things get a little bit more interesting, or certainly at least a little bit more helpful. So this is an example from some of the original Mandiant work, which I'll refer back to additionally, as we move on here. But looking at an indicator of compromise as a composite object that includes multiple values that are linked together via Boolean statements that identify not just a single observation, but rather a series of linked or connected observations that highlight a known bad intrusion or something that's been observed historically as part of an investigative process. Now, the thing is, if we start reevaluating the indicator of compromise as a concept, and getting back to pivoting here in just a second, atomic observables, just items on their own, an IP, a domain, a hash value, are frequently conflated with indicators of compromise. Now, while IOCs can be rightly denigrated for shortcomings and lack of context, that argument is somewhat problematic because we're really treating something like a straw man by disparaging indicators, and we're talking about IOCs. So if that's the case, can we build something out of indicators and IOCs? Well, there's still some issues here, and this is more of a DEFR thing than it is a CTI thing. Well, I guess CTI is a subcomponent of DEFR, but you know what I mean. IOCs and indicators are still fundamentally backward looking, even when they have contextuality around them, which can be very useful for forensics, but not necessarily on their own for discovery. But we're going to get back into how we can change that in just a bit. Because what we're looking at in this concept is ceding a sort of initiative to adversaries. And we as defenders want to take that back so that we can go forth and identify through pivoting or through other exercises what it is that adversaries are doing and continuously evolve our understanding of adversary operations. So to get beyond mere indicators or raw atomic observables, we could look at things like the original IOC concept as promulgated by Mandiant analysts in the early 2010s. These are very interesting articles worth reading to really get into some of the background for what gave rise to IOCs and how we're not necessarily using them appropriately today. And if we look at this mechanism of IOC formation, we see something really interesting. We start with initial data collection and observations, that sort of raw inputs of taking in observations from the world around us, and then transition into, through enrichment and analysis, into initial observables and raw indicators, which is a useful first step, but not where we want to go, because it's through further analysis and production, you'll see where I'm going here in a second, that we get enriched and contextual IOCs that contain context for how the adversaries are using them, as well as giving us the background necessary to start expanding our scope to identify like or similar objects. And you'll notice that this overlaps rather nicely with the linear model of intelligence production from the US Department of Defense's Joint Pub 2.0 on intelligence, where that original collection gets us initial data points that can be further processed into initial indicators, but then by linking these items together and identifying how they fit together, we start getting into finalized intelligence or indicators of compromise that can be helpful for follow-on analysis and pivoting purposes. So looking at IOCs as composite objects, we start getting into something that's a bit more interesting. So looking at IOCs as built from multiple observations and data points gets us to the point where we can start breaking down a unitary indicator to reveal the more fundamental nature of how that indicator is built or what it consists of, that can start identifying links to other indicators of compromise. If we start looking at IOCs as composite objects, and not just in the classic Mandiant sense of looking at a bunch of interlinked indicators, but even the indicator itself by analyzing what items give rise to that indicator, as we'll see in just a second, we can start looking for other items similarly constructed or with similar composition to yield follow-on observations. So for example, let's talk about network indicators for a second. So we're all familiar with malicious network infrastructure observables, domain names, IP addresses, SSL TLS certificates. But if we start diving down into these a bit, we start seeing more components to these than just the domain, the IP. And this was also referenced in the keynote today in trying to hunt down the Sunburster UNC245 whatever network infrastructure, that a domain isn't just a domain, but it consists of where it was registered, who it was registered by, authoritative name servers associated with providing DNS responses for that domain, a naming theme, like am I using tech concepts? Am I using banking spoofing or something else along those lines? IP addresses break down to who's hosting it, where is it hosted, what services are associated with it, and what versions or other sorts of characteristics around those. And then on the certificate level, who's issuing the certificate? Is it Let's Encrypt? Is it Sectigo? Is it self-signed? As well as the actual data for the certificate itself. And all of these items come together to enable for cross-pivoting between them based upon observations in order to yield additional items. Well, the same applies on the file basis. So from a malicious file, the file itself, not the hash. If you can get any of this from just the hash, good luck. Typically, that means you go to VirusTotal and pull the file. But anyway, we get things like static observations, looking at things like file entropy, imports and exports, plain text strings, metadata items. So compilation time and language, the file name that was used, the origin and context, if we have that information, where it was found, where on the operating system it was located in terms of file path. But we also get things like detections and notifications, what antivirus signatures or YARA rules this may have flagged off of, as well as behavioral contexts for network behavior, system behavior, and related and drop files. All of these items link together in order to identify what are the components of this malicious file, and using some of these components, we can try to identify similarly structured items. The way that I look at this is like similarly like you would see in physics, a element consists of atoms, and those atoms may be fundamental building blocks of what that given element is, but the atom itself breaks down into certain subatomic particles that enable the expression of certain features or certain qualities for that atom in question that allows us to start linking to other similar items in terms of the specific nature of the outer electron shell, for example. And so you get things like noble gases or the insanely reactive first column of the periodic table. By applying that same sort of concept of looking at these underlying features that give rise to the characteristics of indicators, we can start moving out and expanding into the discovery of other items in a way that can be more systematized. And this allows us to start, as part of a security investigation, to look at links, whether in terms of both our own internal data sets or to go out and hunt in external data sets like a VirusTotal, DomainTools, etc. So from logs and behavioral artifacts, we can start getting into what are those specific file and malware samples in question, how do they appear, what are their components and characteristics, what were the C2 items that were analyzed, and what sort of adversary tendencies were linked to those observations. And by moving between these different elements, between what we see within our own environment and then analysis of the specific observables that we've identified and their nature, or what items or subcomponents make them up, we can start looking for other similar items and gain a fundamental understanding of adversary behaviors. Because that's what we're really trying to do here, is looking at observations in such a way that we break them down to composite objects from the indicator itself that gives us an understanding of how that indicator was formed and the underlying tendencies that gave birth to it. By understanding those tendencies, we've now moved away from just pure indicator matching and analysis towards an understanding of adversary behaviors and tendencies. So to give Dave Bianco the obligatory mention here, we've moved up the pyramid of pain from just the indicator to what are those items in terms of fundamental behaviors and TTPs surrounding that indicator itself. And so breaking this down into specific observables, we see this collection of items that then, by seeing how these specific observables are linked together, yield the generalized tendencies and behaviors for how that adversary operates. That gets us to the point that the purpose of pivoting is not finding all the IOCs. And frequently it seems like that's the case, that we just want to, like collecting Pokemon, we want to catch them all. Well, that's not what the purpose of pivoting should be. Rather, what we should be trying to do is identify what are the behaviors and fundamental nature behind the adversary in question that can enable for more robust as well as adaptive defense. So looking at pivoting as a behavior-focused item, we see indicators that are linked through behavioral commonality based upon the subcomponents that gave rise to the observations. By understanding those underlying behaviors, we then enable ourselves to discover further items that exhibit similar tendencies. And that behavior-centric approach, while it's going to yield more indicators, because that's kind of our unit of exchange here for this analysis, really is designed to highlight the relationships between these indicators and IOCs rather than just getting the IOCs themselves. And this is a cyclical process. So we want to start by our initial observations and move into the assembling of composite indicators, but then understand the components that underlie these indicators to formulate or document the behavior underpinning the IOC, which gives us the ammunition required, or at least the understanding required, to search for objects that match similar behaviors. But once we've done this, we want to go back and then assess the appropriateness or closeness of fit for new observations to the original data set to see if we're on the right track or not. Because if we fail in this iterative cyclical process of going back and assessing closeness of fit, we risk the likelihood actually of going off the path of the behavioral similarities that we were tracking further and getting into unrelated, if still malicious activity. So we want to make sure that we're continuously adapting and focused on what are the behavioral commonalities or the clustering in question for the entity that we're tracking, and make sure that we continuously check our work as we go through this process. This behavior-based pivoting is really centered on trying to find like behaviors to flag similar observations. Now, certainly IOCs are necessary, but they're not exclusive, nor are they the only thing that we should be focusing upon, because the end result of pivoting is going to be a better, more complete understanding of the adversary that we're actually chasing down. So what does that look like in practice? So we start seeing a combination of network observables and host and file observables that yield all of these other subcomponents or observations, from infrastructure characteristics to plain text strings to PDB strings to hosting tendencies. And by looking at these artifacts and subcomponents, we can start developing query criteria, whether in internal data sets or through external data sets, to try to fuel hunting and analysis to discover additional items related to that adversary based upon how they link to fundamental tendencies from the original data set that we started working with. So to develop a matching methodology here, we want to try to identify how that adversary acts and what conclusions we can draw from those observations. All right, well, anyway, I think what I was leaving off on, please correct me if I'm wrong, is we've gotten to the point where from analysis of technical artifacts, we can begin extracting behaviors from them in such a fashion that we can leverage data sets to search for additional IOCs and subcomponents. But the goal there is not, again, the IOCs, but rather to ensure that we're understanding the links between our original data set and the new observations that we've been able to unearth in order to build an understanding of the fundamental ways that the adversary has been operating. So how does this look in practice? Well, this is a very deliberate choice on my end, since we talked about this yesterday in an excellent presentation by a couple of the researchers over at the FireEye team. Let's look at the keg tap and single mult activity, which is somewhat related to the UNC 1858, 78, I forget. Anyway, another UNC ransomware related UNC activity. What was interesting about this, and actually going back a slide here, if you look at the panel on the right, we see, and this was something that was emphasized yesterday as part of a campaign that was impacting a number of hospitals, the analysts at FireEye pushed out a number of domains that were related to the activity in question. Well, that's good for looking at things that were either historical or valid up to the point of that publication. But from a defender standpoint, we want to get into a position where we're not just playing whack-a-mole on historical items, but trying to identify things moving forward that could allow us to adapt defense. So how do we start identifying what these domains mean and how they're interlinked? Well, using tools and visualizations, in this case, this is a DomainTools Iris visualization, we see that there are fundamental links or connections between how these domains work that allow them to break into two distinct clusters. On the one hand, we have a set of activity that's hosted in Switzerland and related to a specific ASN, and then another cluster that's hosted in Germany on another ASN, but both clusters are linked through the use of the Namecheap registrar and the use of the .com TLD, but also in terms of naming conventions, and this is more of a human eye test sort of thing than a technical analysis standpoint. We see sort of technical themes referenced in how these items are observed. So the use of driver, service, etc., that if visualizing this or just looking at a list of items can allow us to pick these out. Also not pictured here, there is commonality in the SSL TLS certificates, specifically with the LOL comment in the certificates, because these people are assholes, to be quite frank, that get us to these fundamental tendencies here. Again, the use of the TLD, the primary ASNs, the use of the Namecheap registrar, and then the tech domain theming. Well, based upon that, we can start searching on those characteristics to try to identify additional items that hadn't been linked concretely to this activity and can allow us to adapt moving forward or identify as it's created additional infrastructure thanks to our understanding of that behavior. So in this case, while we certainly get additional indicators, if we're employing some sort of auto enrichment on things like new network connections, we could utilize that in such a fashion to immediately flag items of interest that match the patterns of known activity, or at least known historical activity linked to a certain adversary. Now, another example to keep with a ransomware theme, right before the holidays in 2020, there was a Bizarre Loader campaign that took place. That was, I first learned about it from a tweet, and then I wrote an article about it later on with lessons learned. What was interesting about this, though, is that, and this is a screenshot from the blog in question, you can see that, okay, hash values, that's fine. But file names, we start seeing something here that looks interesting. A commonality in file naming conventions of corp, document. There are a few other themes that, if you start looking through them, referencing PDFs and whatnot, but all exe files. So PEXE files with document themes, like, okay, that's something that should automatically stand out as being very suspicious, but provides insight or initial fuel for looking for other samples. But more importantly, these samples had another item in common that was much more robust in linking them: the use of a signing certificate. So the certificate had been revoked by the time I took this screenshot, and this is from VirusTotal for those who are wondering. So this OOO, which is a Russian translation for ink, and then the organization name. Now, what's interesting about this is that there were a couple of certificates that were used. So signed malware is always kind of gnarly, but it's not new anymore. We need to kind of adapt to this. But using this same certificate pattern, so using Cyrillic items that were signing the various Bizarre Loader samples. So with that, we can start identifying some high-level tendencies for this malware to enable hunting and analysis. So the company, corporate, whatever, and similar naming themes, signed PXE files using a Russian language Sectigo signing certificate, as well as a commonality in file size that can allow us to sort of limit what it is that we're looking for. Well, based on those criteria and using something like VirusTotal Intelligence Access, we can look for items that match this. And this is an updated screenshot. If you looked at this actually on like the 22nd or 23rd of December, the detections for these were all in the single digits and often in the low single digits. So by virtue of just identifying the tendencies related to this malware, we can see how these things are related to each other and unearth not just additional samples, but samples that are linked to a fundamental way of how the adversary was operating, which is interesting because this same sort of behavior cropped up yesterday or 2 days ago in another Bizarre Loader campaign with the same use of that same signing certificate structure, similar naming themes, and PEXE files that were similarly delivered. So if we were adapting this way of identifying newly observed files in our environment, you would have been more than prepared to meet this follow-on campaign 3 or 4 weeks after the one that we originally documented without necessarily having to rely on AV or whatever, just an ability to rapidly enrich and analyze portable executables as they were introduced into your environment. So where does that get us? So from a pivoting lesson standpoint, we want to start by gathering initial observations and then use that to understand commonalities among those observations. You know, all these things, how are they similar? How are they linked together? Then based on those links, we want to start leveraging data sets to search by those characteristics and then go back to the original data set to assess closeness of fit. How do objects that seem to be similarly structured based upon the links I identified earlier map back to my original known malicious data set? I could then use that discovery to refine observations that map to adversary behaviors to gain greater insight into adversary tradecraft, and then apply this process in a continuous iterative fashion to make sure that I, as an analyst, are co-evolving with my adversary throughout this process. So to conclude here, and see, I'm actually roughly on time despite a couple of technical hiccups, pivoting simply must transition from an art to a science. We can't just say, hey, that looks bad or this looks similar to what, no. We need to come up with a way of consistently documenting and then a process that can be both documented and repeated by other analysts. Doing so requires that we have an understanding of our primary observations, typically in the form of an indicator or an IOC, and understand how we can break apart these items in order to yield follow-on observations. By applying a very rigorous and behavior-centric searching mechanism, we can get greater accuracy and repeatability in these processes that can, well, we haven't exactly developed something like a formula or something along those lines for pivoting, but by looking at pivoting in this sort of fashion, we can very much transition into a more sustainable and definitely more accurate process moving forward. Now, there's a number of references linked to this talk. There's actually far more than this. I'm working on a paper related to this. It would have been finished already, but SolarWinds has been kicking my tush. So I haven't been able to devote as much time to writing up a white paper related to this. It's about 2/3 of the way complete. So I'm hoping in the next week or two, that'll be available. So stay tuned to my Twitter feed or DomainTools for when that comes available. but I know that we had some issues and we're running a little bit behind. If we have time for questions here, great, but I'm going to go into the hallway and you can certainly harass me there and talk about my crappy internet connection there as much as you'd like.